Hello everybody, I will starting a new chapter for you. I will start the lipid chapter because it's so more difficult than carbohydrate. I hope all to study. I wanted to make an appointment for you, but it's not suitable because our college it's passed lots of lectures and we consume lots of time. So I preferred to make a lecture now as online and start so difficult chapter. It's called lipid. My lipid, it will be on 2 lectures. Every lectures you will have one A3 paper plus a computer paper. If you study this paper so hard and so very good, you can pass my computer paper and you don't need it for seeing or for studying. So that's enough for me to study this A3 paper. Okay, I wanna from you to study this and answer the questions after ending of each lectures. Okay يا شباب? Okay for the use. Okay, we start now lipid chemistry. Okay, on this one A3 paper as we agree. Okay, if any lipid structures, it must have 2 major compounds: fatty acids and glycerol. Fatty acids and glycerol to make the most common triglyceride or triacyl glycerol. So we have 2 major compounds: fatty acid and glycerol. Why? To make unique compound is called tag. What is meaning of tag? It is triacyl glycerol. Wow, which is the major component of our cell structures, which is the important constituent for fat, which is stored in adipose tissue. Yes, which make us obese. Oh la la, obese. Fatty acids and the glycerols, like building units, to make a big compound is called tag, triacyl glycerol or triglycerides. Yes, which is make a solid fat in our human body structure. So, which is a constituent in cells, build cells and stored in our cells, which is called adipose tissue. Adipose tissue, if you have many or lots of adipose tissue, you look like an obese man. Okay, now I start with you fatty acids as structures, as chemistry, and after that, and after finish the fatty acids, we will study tag triacyl glycerol. Our A3 paper is divided into 2 parts. The upper part is fatty acid, and the lower part is tag triacyl glycerol. Okay. Any fatty acids chemistry, it has R side chain and carboxylic group, 2 groups of fatty acids. Okay. Yes. R and COH. Focus on this structure. R is called side chain. COH is called carboxylic group. It is the main structure of fatty acids. So I describe this word in 3 words is so important. The first word for describing the fatty acids, amphibasic. What's meaning of amphibasic? Amphibasic, it means in this structure contain both group, polar and non-polar. Fatty acids has 2 groups. Side chain, it is non-polar group with COH polar group. Doctor, what is the meaning of polar and non-polar? Polar meaning hydrophilic. What is meaning hydrophilic? Hydrophilic, like I love water. Hydrophilic, I love water. Hydrophilic meaning love, polar, loving water, or soluble. But non-polar, it is the opposite. What is meaning hydrophobic? I hate water. Hydrophobic, I hate water. Or insoluble. I cannot miscible with water. Water is a solvent which is dissolving any molecules, but the water may dissolving fatty acids or not, according to the side chain. If the side chain is short or medium, the fatty acids will be dissolved. If the side chain is so long, the fatty acids is insoluble, cannot dissolve it in the water. Okay. The fatty acids, amphipathic, mono-COH. Which is the meaning of mono-COH in one carboxylic? Mono, it means mono-carboxylic, one COH. Okay, the other next word, straight chain. Straight, the chains of the R, its meaning of carbons. It is linear, not branched, RCOH. Okay, your straight chain means is linear, not branched. Our triglycerides doesn't contain any branched. Yes, it's a straight linear. It's amphipathic, polar and non-polar. It is mono-COH. Okay. The other word in this green window, wow, even number. If any or any fatty acids has number of carbons, the number of carbons must be even, not odd. Not odd, is even. Even number. Why? As it's a more common. It's the most common in natural. Yeah, it's most common in natural, except. What is the exception? The exception is fatty acids which is present in milk and the cell wall. CW, it's abbreviation of cell wall of bacteria. When here there are three examples of these odd fatty acids: propionic acids and the valeric. Propionic acids has 3 carbons and the valeric has 5 carbons. You must save these 2 fatty acids because they are exception. They are exception. As in natural, all fatty acids are even. All fatty acids are even. In our human body, forming our cell structures are even number. Exception 2 fatty acids, propionic and the valeric, example in the milk and cell wall. This note I discussed before, as a solubility of fatty acids may be short, may be long. If short, it will polar, yes, and dissolving in water. But if long, it is non-polar due to side chain. So I can make a deduction of our speech. Yeah, of my speech. What? If fatty acid short in my body, it will be transported in the blood without any carrier. But if the fatty acid is long and transported in the blood, it needs carrier. It must need carrier. Example الالبومين. Example ايه؟ الالبومين. طيب. The other window. Wow. We have general structures of fatty acids. COH, mono, like a one, mono is one COH. And side chains, which is carbons, linear, not branch. Carbon, no, we will have the terminal carbon. It's called methyl or terminal carbon, which is called omega. Yeah, methyl last carbon in fatty acid structures called omega carbon, like omega 6 and omega 3 of fatty acids, methyl end and the carboxylic end. Okay. After COH, we have a carbon. It's called the first carbon. After COH, it's called alpha carbon. The next beta. The next is a gamma and a also. Okay, I have the important carbon for me is alpha. He is the first important after a COH. It's called alpha. And the next A is not important. Okay. Which of the following is important in this window or in this fatty acid structure? The first, COH, is carboxylic, and the terminal methyl, which is called omega. In normal, if you decide to number this fatty acid, you must start from a COH, like carbon 1, carbon 2, carbon 3, and make continue. Okay. If you wanted to start from this omega, it's in special cases. It's in special A cases, okay? If you wanted to make to calculate the numbering of fatty acid according to its omega A6 or omega 3, you will start from the terminal methyl. Okay. That window, it's not important, but like a reading a journal. Okay, what is the function of lipid? Energy storage, cell membrane structure, okay, in our human body. Precursors, what is meaning of precursors? It's like a substance which is produce another substance, but it's very important for us. Precursor, steroid hormone and vitamin D. Steroids, hormones, vitamin D. Thermal insulator, insulate us from and isolated us from the temperature. Like in the winter, if you are obese man, you don't feel any of the cold weather. You don't feel anything from the cold weather. You look like in the summer, okay? And protection internal organ like GIT, as example, it covered lots of fat in our dead bulk. Okay. طيب. Now we will start classifications of fatty acids according to the presence of double bond. According to double bond. If double bond is absent, we will call this fatty acid as saturated. If the double bond it is present, you will call unsaturated fatty acid. Okay. Insaturated fatty acid, which has no double bond, Okay. So saturated may be short or medium according to number of carbon. This saturated is classified according to the number of carbon, may be short or medium. It means which it means less than 16 carbon. If more than 16 or equal, we will call it long. We have examples. You must save it in your brain. If less than 16, you will have 12 carbon lauric acid. 14 carbon is called myristic. You must save it. But the long is so important for us. It's more equal or more 16 palmitic acid, 16 carbon, and 0. 0 means no double bond. Stearic 18 in Arabic, 18 carbon and no double bond. The long fatty acids has advantage because no odor, no taste. But the short and medium has odor and has taste. Odor, irritating odor, and the souring taste. Okay. Saturated has unique properties, yes, because no double bond, like high melting point. If you want to melt this fatty acid, you will consume high temperature to have melted fatty acid, like a melt, like a water. No double bond, it's solid. It's a solid, yeah. Saturated, SS, saturated solid like animal fat. If you have saturated fatty acids, it must end in systemic name by suffix called anuic. If you have butane, butane for carbon, yes, it's alkane organic compound. Butane weak is called butane in acidic structure, butane weak. If it is unsaturated, you will call it butene weak. Butene in is alkene double bond. طيب اوكي ده كده saturated. Let's start unsaturated. Unsaturated, it has one or more than one double bond. It has double bond. The melting temperature less than saturated because the presence of double bond make fatty acid is so weak. The double bond is present in cis form. Cis. What's meaning of cis? Cis like that. If you make a carbon like that, yes, this called cis. Why? Because these groups are drawn as you see. These compounds or these groups are in the same direction. As you see now, 2H are in same direction but are in the other direction. Okay, it's like that. If you see that, you call it in cis form. But if the H are not in the same direction, like if you remove it and make it here, oh la la, H and H are in opposite direction. So it's right, are in opposite direction. We will call it trans. A trans is the so rich fatty acid. It's so rich because our body cannot use or utilize or oxidize them. It will be deposited in our cell bodies like arteries, coronary, in our heart, and you will have atherosclerosis. Okay, bum. طيب, let's continue. Unsaturated double bond cis form liquid vegetable oils, but the animal fat is solid. Yes, in saturated fatty acid. Saturated fatty acid solid, animal fat, but unsaturated liquid, it's a constituent from vegetable oils. Okay. The examples of unsaturated is so important. The examples of unsaturated, it's so important. Okay, we will have mono and poly. Mono, one double bond. Examples. Palmito-oleic. What's meaning of palmito-oleic? Palmito-oleic is palmitic acid, but you add one double bond, so it's called palmito-oleic. 16 carbon with one. One means one double bond. Delta 9. Which of the meaning of the number is above this delta? Yeah, delta like a triangular, which is drawn. The 9 is the location of double bond. The 9 is the location of double bond. You must know and save it in your brain. It is the location. What it means? It means in this double bond it's present between carbon 9 and carbon 10, not carbon 8 and 9. No, but is carbon 9 and carbon 10 always. The number of delta is expressing for the lower number, the lower number of carbon. Yeah, F9, it will be the double bond located between carbon 9 and carbon 10. Yes, oleic acid, it is stearic. Yeah, 18 carbon, which adds one double bond between 9 and 10. 18 carbon, 1 delta 9. 18 carbon, 1 and delta 9. Oleic acid. Oleic. If you have fatty acid has more than one double bond, we will call it BUFA or polyunsaturated fatty acids. This abbreviation is so important because we will dispense our money for buying it because our body cannot synthesize them. BUFA. What is meaning of abbreviation? Polyunsaturated fatty acids, essential fatty acids. Essential. What's meaning of essential? Essential means our body not synthesize it. So I make wrong. I make X. But our diet is right. My diet, yes, it's containing in our diet. I spend lots of money to have this proof in diet, like fish, like plant oils, like vegetable oils, like supplement from the pharmacy, omega-6 and omega-3. Okay, بوفا more than one double bond. Example مهم جدا, so important, so important. Linoleic acid. Which is meaning linoleic? Linoleic is stearic acid. Linoleic is stearic acid. Linoleic is stearic acid. But we add 2 double bond. So linoleic 18 carbon and 2. 18 carbon and 2 double bond. What is that position? Delta 9 and 12. Oh, what is that? You must know. The space between each double bond is 3 carbon. The space or the distance between double bonds, it must equal 3 carbon. Yeah, if we have the first double bond at carbon 9, you must know in the second double bond at carbon 12. Yeah. Okay. Linoleic equal linoleic, but in the linoleic has 3 double bond. 18 and 3. 3 double bond. What is the position? What is the location? Delta A 9, 12, and 15. Oh, note that the space between double bonds is 3 carbon. 9, 12, 15. The final bufa fatty acid, it's so important for human body. It's called arachidonic acid. Arachidonic has 20 carbons, 20 number of carbons, and 4 double bonds. It's unique. Yeah, 4 double bonds, and is a position located from started delta 5, 8, 11, 5, 8, 11, and 14. The spacing between double bonds is 3 carbon. Omega. Wow, what is meaning of omega? Before starting, what is the meaning of omega? I must say the important note for arachidonic. What is meaning of arachidonic? Arachidonic is PUFA. It is polyunsaturated fatty acids. It is important for biosynthesis of substance which is called prostaglandin. Prostaglandin is substance. It is appears in our body during inflammation. Prostaglandin is called important unique word. You will hear it later. Prostaglandin eicosanoids. Prostaglandin is a eicosanoids. Eicosa, it's mean 20 carbon. Oids is like compounds. Prostaglandin is synthesized from fatty acids, so important for us, is called arachidonic. Okay. What's meaning of omega? Omega, linoleic omega-6, linolenic omega-3, arachidonic omega-6. How can we know the omega number? How can you know it? Okay. If you want to make or to know the number of omega, you must know that important thing for omega. How? Or what? Omega-6 means the first carbon, which is numbered from the terminal methyl, is called carbon 6. Or the first double bond, appeared to me if I number from the terminal methyl. If you number from terminal methyl, you will have the first double bond. If the first double bond has a number, so this number is omega. So this number is omega. Okay. Linoleic is omega-6. What means omega-6? The double bond number 6, when I numbered from the terminal methyl, not carboxylic, not from terminal methyl, is called carbon 6, is called double bond at carbon 6. Oh, okay. I must draw now this structure of fatty acid to calculate the omega number. I think it's so difficult because our exam time is so short duration. Yeah. How can I draw each fatty acid to calculate its omega number? It's so difficult. So I will tell you the rule. If you work on it and use it, this is my unique rule, yeah, you can calculate any omega of any fatty acid you see. What is the rule to calculate the omega carbon? Okay, this rule, it's like Abdel rule. Abdel rule to calculate the omega number. Omega number. It's called a total number. This its abbreviation. Okay, NO dot. Total number of carbon minus a number. أيوة of ماشي last أيوة double bond. Okay, omega number equal total number of carbon and the number of the last double bond, like that. What is the total number of carbon of linoleic? 18. What is the number of the last double bond? 12. Okay, 18 minus 12 equals 6. So I calculated the number of omega carbon. Arachidonic, for example, 20 number, 20 carbon, minus the last double bond, 14. 20 minus 14 equals 6. Like, for example, 18 minus 15, okay, equals 3. What is meaning of 3? It's omega 3. It's omega 3. Okay. We must know now. Okay, guys. Now we will continue our discussion. The fatty acids. You must know about the fatty acids. It may be essential or non-essential. Okay, we know that is PUFA is called essential. It must be in diet. Our body not synthesize them. Okay, but the other. Which was from the other? The mono and the saturated. The mono and the saturated are non-essential. The mono and the saturated are non-essential. Okay, but the PUFA is very essential. Essential. Okay, but I will tell you a unique note. Yes, which of the following note is so important about arachidonic? Arachidonic is essential only if this linoleic is absent. هو essential in absence of a linoleic. Why? You must know important note about arachidonic. You must know important note about linoleic. In this linoleic, yes, is a precursor. A precursor. What shows the meaning of precursor? Yes, it's substance which is produced and another substance which is so important, like us for the arachidonic acid, which is used for biosynthesis of arachidonic acid. Linoleic acid is a precursor of arachidonic. If you eat linoleic, you will synthesize arachidonic. So arachidonic is non-essential in presence of linoleic. Yeah, like arachidonic act as semi-essential. It may be essential or non-essential. If this precursor is present in our body, if you eat it, if you have it in your diet, so arachidonic it will like as non-essential. But if linoleic is absent in our diet, so you call it arachidonic is essential. So you can express this arachidonic acid as semi-essential. Is semi-essential. Which of the meaning semi, not semi-final, but semi-essential. It act like as essential or non-essential. Essential must be in diet because our body not synthesize them. Arachidonic not synthesized in absence of linoleic. But non-essential, you don't need it to have in your diet, because as arachidonic, if you have linoleic in your diet, you don't need any arachidonic because your body synthesizes it from this linoleic. This linoleic is precursor of arachidonic. Okay, if linoleic absent, so arachidonic is called essential. It's called essential. Okay. What else? What is the function of essential fatty acids? What's the function of BUFA? Gross cell membrane structure. It's also cell membrane. Like as phospholipid, PL, it's abbreviation for phospholipid formation, and we will discuss phospholipid in other sessions. Okay, skin, yes, skin formation. Essential fatty acid is important for skin structure, like PUFA. Reproduction, yes, for male and female, for make a baby and they get a baby. Against the fatty liver, yes, protection from the fatty liver, which is lots of fat deposited in my liver, and the liver functions will be impaired. Retina in my eye for vision, so you must have essential fatty acid for this vision and energy production. If you have essential fatty acid deficiency, you will have defect in growth, impaired for growth retardation, dermatitis in your skin, inflammation of the skin, fatty liver. Okay, so this essential can act like protection against the fat liver. So you can get this essential fatty acid in any supplement from the pharmacy. Okay, I bought yesterday Limitless supplement from the pharmacy. Limitless is the name of the product, which contains omega-3 and omega-6 to make protection from any disease like fatty liver. For example, sterility. What's the meaning of sterility? Sterile, like fertility. What's the meaning of fertility? I cannot make a baby. It will have I will make a defect in the sperm or ova. Sperm for men and ova for girl. So difficult for make a baby. So I will be sterile بعد الشر عليا. Sterile or infertile. Okay. So after that I finished my discussion now and finished this lecture is part 1 of lipid chemistry. The next session I will continue this RA3 paper, triacylglycerol, the other part in the second half. I wanted to answer some questions. About the fatty acids. Okay, I wanna answer some questions. Okay. Okay, question break about that. We can answer these questions to be ensured we are so hero after this session of fatty acids. Fatty acids is not easy, it's so difficult, but you want to study this lecture well and hear me a lot to be so hero. The first question, what is the description best fits the term of saturated fat? Okay, the right answer is A. Triacylglycerol molecules which fatty acid chains contain only single bond. That's right answer. The second question, essential fatty acids, which is the following as example of essential linoleic or linolenic or arachidonic or all of the above? Yes, the right answer is D, all of the above. The question 3, a fatty acid not synthesized in body and has to be supplied in diet. Palmitic no, stearic no, palmito oleic no are not essential but non-essential. So linoleic is the right answer. The number of double bond in arachidonic 4 double bond, but linolenic 3, but linoleic 2. Question 7, 20 carbon of fatty acids is called arachidonic acid. And the last question, stearic acid, stearic acid 16 carbon or 18 carbon or mono, unsaturated or BUFA. Yeah, stearic acid is 18 carbon because it is saturated and the longest, so long. Okay, I finished the answer of the questions about our lecture, and now we can say bye bye fatty acid and welcome to triglycerides in our next session. Okay, see you soon. Bye bye.